Yeah, next to coenzymes and cofactors, so we are going to study about enzyme activity modulators. So we have two different types of modulators. One is activator and another one is inhibitor. And allosteric enzymes may be controlled by the effective modulators. Both are activators and inhibitors. And so these activators and inhibitors are nothing but so this will modulate the enzyme activity. And enzymes, they have a separate binding site for the modulators, and this modulator binding site is called as allosteric binding site or regulator site. And so we are going to have a detailed discussion about that one. And the next one is isoenzymes, and isoenzymes are nothing but the enzymes that differ in amino acid sequence, but the catalyze the same function. It is same function but a different shape or configuration or different 3D shape. Okay, so that is the isoenzyme. Iso means same enzyme, that is same catalytic activity but different configuration or different structural conformations. And these enzymes have different apart from having same catalytic function, but it may differ in all the enzyme kinetic activities, like the kinetic parameters such as Km or Vmax, and Ka also may be the different for each and every isoenzyme, and it is not same. So that means that the catalytic reaction is common, but all the enzyme kinetics and also the 3D configuration, everything is different. The best example is lactate dehydrogenase and creatine kinase. Both enzymes are very much involved in diagnostic aspect. That is clinical enzymology, and these are the two markers for myocardial infarction. And when compared to both the creatine kinase, that is more effective and more confirmative than LDH. So next, coming to the allosteric enzymes. In the biological systems, the rates of many enzymes are altered by the presence of other molecules such as activators and inhibitors. And collectively known as effectors. These effectors are called as the positive effector and negative effector, or positive modulator or negative modulator. The end product of the each and every metabolic pathway will control the first enzyme, that is the first enzyme's active site. So that is why it is called as metabolic regulation. So this regulation is a very important point. That is the first enzyme of each and every metabolic pathway, and preferably the middle or the last enzyme of each and every metabolic pathway is controlled by the particular component. That is modulators. The modulators having the function, that is it may alter the kinetic characteristics, and based on the stimulation or inhibition, it is called as stimulators or the positive modulators, and the inhibitors or negative modulators. And so we can categorize these two types into further types, that is homotrophic and heterotrophic. And homotrophic is nothing but the same substrate may act as a modulator. It is called as homotrophic. Homo means same, both the substrate and the modulator, that is modulating substance, the compound is same. That is what is called as homotrophic. And heterotrophic is nothing but that is different, entirely different. The substrate and the modulator are different. And this modulator binding site is also different. That means if the substrate is different and modulator is different, means the modulator binding site is also different. The allosteric enzymes are structurally different from simple non-regulatory enzymes. That is, we have two different types. As I told earlier, the enzymes behave in a different way. That is, the enzymes are controllable enzymes and the enzymes non-controllable enzymes. Controllable enzymes are nothing but the regulatory enzymes, and non-controllable enzymes are called as the normal mechanism obeying enzymes. And apart from the active site or catalytic site, the allosteric enzymes also have one or more regulatory or allosteric sites. This is very important. The allosteric site is apart from the regulatory site, and the allosteric site is specific for its modulator. Enzymes with several modulators generally have different specific binding sites for each. So we can have an example, the aspartate transcarbamylase. It is a multi-enzyme complex, this aspartate transcarbamylase has 12 subunits. So we can have an example. So if you are plotting the values of substrate concentration in the x-axis and velocity, that is V0 in the y-axis. The V0 is clearly defined as a micromole amount of products formed per minute, and the substrate concentration, it is here represented as the millimolar concentration of the substrate. If you're plotting the values of the substrate concentration versus velocity, so this will give a different this curve. It's called a sigmoidal curve. And compared to the normal Michaelis-Menten obeying enzymes, with that is the sigmoidal curve will not be formed there. The hyperbolic curve. There is a hyperbolic curve formed in the normal enzymes, and the regulatory enzyme sigmoidal curve is formed. It is slightly S-type curve. This is one, and this the formation of the speed of the reaction is not comparable to the normal one. So this the formation of the velocity is not much similar to the normal one. Here we can have an example. The sigmoidal curve is the proper significant parameter for this allosteric enzyme, that is highlighted here in yellow color highlight. And the non-regulated enzymes are hyperbolic curve. So that is we have to remember that one. The allosteric enzymes, however, do not obey the Michaelis-Menten kinetics. And this is the plot. Maybe if you are adding the modulator, we have the positive modulator, negative modulator. We have three different hyperbolic curves. The central curve mentioned as 0, that means without any modulator or inhibitor. And the first one, the minus sign is there. So this minus sign is nothing but this minus sign is very significant. That is the inhibitor, negative modulator. The presence of negative modulator, the speed of the enzyme, that is velocity of formation of product, is decreased when compared to without any modulator. And if you're adding the positive modulator, the velocity is increased. At the same time, the Vmax is reached a little faster when compared to other two categories. And the apparent Km, that is the Km is nothing but the velocity Vmax divided by half. And I will explain to you by using the pen. So this is negative modulator obeying enzyme, that is with inhibitor, and this is 0. That means there is no inhibition. That means no modulator is added, and this is positive modulator. And this is Vmax, the maximum velocity achieved here. This one is called as, this value is Vmax. The Vmax divided by 2. That is this value, this point. That is the blue color dots are given. So this is Vmax divided by 2. So this Vmax divided by 2, the corresponding to the concentration of the substrate is called as Km value. You can see the different Km values for that is without any modulator, or with the positive modulator, with the negative modulator. You can see here the Km value is K, that is 0.05. That is effector the Km value, the apparent Km value. So here, if you see here, this is substrate concentration is much more needed for that is a K to attain a Km value. So this one is entirely different, and you can see the differences. So this is evident that this binding of the effectors or modulators to the that is apart from the substrate binding site, that is apart from active site, that is called as a regulatory site.